voice coil motor simulation in QuickField. In this example, I'm going to simulate the magnetic system of the loudspeaker and find the flux density profile in the air gap, where the voice coil is located. Remember, it is essential for the loudspeaker to avoid the distortion to have an uniform magnetic field distribution in the air gap for any possible position of the voice coil. The permanent magnet is made of ferrite with the coercive force of 500 kA per meter, and the core is made of soft steel. You can see the BH curve here. The problem features rotational symmetry, so I'm going to simulate two-dimensional magnetostatic problem in QuickField. Okay, let's start QuickField now. I create new problem in QuickField. Voice coil motor. Next. Problem type is magnetostatics. Length units are millimeters. Model class is axisymmetric. Axisymmetric means that the model features rotational symmetry. Finish. On the left you can see the problem pane, and on the right you can see the geometry model editor window. You can draw the model here, or you can import the geometry model from the AutoCAD.xf file. Click in the geometry model editor window to make it active, then follow to the file, import DXF. Here is the file and I will import it. You can recognize permanent magnet, core, and a voice coil. In axisymmetric problems, the axis of rotation is a horizontal one, this one. So we should rotate the model. Right click to select, move selection rotation by 90 degrees. In axisymmetric problems, you should draw only the upper half of the cross section. So I drag the geometry model here, switch to insert mode, straight line, and draw the axis of the rotation here. Now I switch back to select objects mode and remove the bottom part of the model. Okay. So here we have a permanent magnet, the core, the voice coil. In fact, the magnetic field is distributed not only in these parts, but also in the air outside. QuickField cannot calculate field distribution in the infinite space. We should limit the simulation domain. So again, switch to insert mode, change line type to half arc, and draw the air block boundary. Next step is to assign labels. Through labels we will explain the geometric object's meaning and provide material properties. Again, switch to select objects mode. Click the block to select and type in the label name here. This is air. Click here, this is permanent magnet. Click here and here. To select multiple objects at the same time, hold the Ctrl button pressed. So these two blocks are, and here you can see there is a voice coil. Okay. I should also assign labels to the boundaries. QuickField automatically assigns proper boundary condition to the axis of the rotation. And for the external boundary, I assign label external. Okay. Now let's provide physical properties for these labels. Double-click the label in the tree. Relative magnetic permeability of the air is 1. Relative magnetic permeability of copper is 1. The voice coil is made of copper. The pigment magnet relative magnetic permeability is 1.05 and the Corsi force magnitude is 500 kilo amperes per meter. The direction is to the left, 180 degrees. Okay. The core is made of ferrite with non-linear dependence of flux density on the field strength. And here in the Excel file, I already have the dependency. Select the data and copy. Then paste it here. Here it is. Okay. And far away from the loudspeaker, magnetic field fades to 0. So at the external boundary, I will specify 0 magnetic potential. Geometry model and material data are ready. Before I start the analysis, I should build the finite element mesh. Just press this button and the mesh will be generated. Now save all problem files and solve the problem. Let's take a look at the results. Here you can see the magnetic field lines. You can adjust the field picture properties and switch on, for example, the color map of the flux density. You can see the correspondence between colors and numbers in the legend. My task is to calculate flux density profile in the air gap, where the voice coil is located. Here. I will use the contour tool. Switch on the contour tool, click here and drag to draw the contour line. Now I can get the flux density distribution along this line. On the XY plot, you see indeed around the coil there is an area of uniform magnetic field. The exact values you can see in the table. Coordinates, flux density, components, and other field parameters. And if I specify electric current in the coil, I will be able to calculate the force acting on the coil. For example, total current is 5 amperes. Run the analysis again. Take a look at the results. Again, I will use the contour tool, but this time I will click to select the coil, open the integral calculator, and here is the mechanical force pointing to the left. If you search for the voice coil on our website, you will find the example page. Here you can read about problem setup, browse the solution section, take a look at the resulting pictures, and download the simulation files. Simulation files may be opened and the results may be viewed using any QuickField edition, including QuickField Student Edition that you can download from our website for free.